Extraction of curcuminoids from turmeric, presented by J. Devaganesh and M. Maheshwaran, final year B.Tech Chemical Engineering, guided by Mr. P. Vinosh Muthukumar, Assistant Professor, Department of Chemical Engineering, from Vailtech High Tech, Dr. Rangarajan, Dr. Sakuntala Engineering College, Avadi. Introduction. Turmeric, Curcuma longa of Zingiberraceae family, is a widely cultivated spice in India and other Asian countries. In modern times, it has been accounted for its anti-carcinogenic properties for the treatment of cancer and anti-angiogenic properties for the treatment of cardiovascular diseases. Cancer is nowadays a major stigma all over the world, and it has been termed as a rich man's disease. Researchers are plenty in this field to make this treatment feasible to the common man. Curcumin is the main component in turmeric, and along with dimethoxycurcumin and bis-dimethoxycurcumin, altogether known as curcuminoids. As shown in the figure, curcumin has 77%, dimethoxycurcumin 17%, and bis-dimethoxycurcumin 3% are present in turmeric. Methodology. We plan to extract these curcuminoids alone. In previous experiments, these have been extracted by using certain solvents. Our idea varies in the usage of different solvents apart from those used in previous experiments. The process involves the use of Soxhlet extraction apparatus. It involves the solvent extraction method. In the first stage, we follow the process as read in the literature survey. This was done to ensure the process familiarity and also the presence of curcuminoids. The turmeric was taken, dried in sunlight and powdered. 20 grams of this powder was weighed and placed in the Soxhlet apparatus. 200 ml of this acetone was heated and reflexed in the apparatus. The procedure was monitored until the yellow color of the extraction faded away. These pictures show the experimental setup and the process which is run. The picture on the right hand side shows the extract which is to be obtained. These pictures show the solvent that is taken. The left hand side shows the solvent at the initial stage, and the right hand side, the after solvent, it has been reflexed. These pictures show the that's the completion of the process. The right hand side picture shows that the solute has been removed completely from turmeric as the color has faded away. The picture on the right hand side shows the final extract obtained from the process. The final extract was concentrated and sent for spectrophotometric analysis to find the presence of curcumin. The sample was analyzed at Anna University ACTech campus for UV spectrophotometry. The components of curcuminoids have lambda max at 420 nanometers, that is from literature. This will be helpful in the analysis. With the analysis, the first stage is complete. This is the result that we got for the sample for UV spectrophotometric analysis with acetone as solvent. The peak was obtained at 413.8 nanometers, which ensures the presence of curcuminoids in the turmeric extract. Selection of solvent. Our target is to use other food-grade solvents apart from those used already. The solvents are chosen according to the FDA's guidance for solvent selection. The use of Class 3 solvents is highly recommended for drugs. Some of FDA's Class 3 solvents are acetone, ethanol, 1-propanol, pentane, and acetic acid. We used 1-propanol and extracted the curcuminoids in the next process due to its high eluent strength, which is 0.88. Second stage. In the second stage, we used 1-propanol and followed the same procedure as in the first stage. The extract was analyzed for the presence of curcuminoids in UV spectrophotometer. Further, the sample was sent for HPLC analysis. The HPLC analysis was done at SRM University. UV result. This is the result that we got for UV spectrophotometric analysis with 1-propanol as solvent. The peak was obtained at 414 nanometers, which also ensures the presence of curcuminoids in turmeric with using 1-propanol as the solvent. The previous results of UV spectrophotometry ensured the presence of curcuminoids in turmeric. To further ensure the presence and percentage of curcuminoids, we go for HPLC. This figure shows the HPLC result for acetone as solvent and the clear presence of curcuminoids, and the percentage as 59.7. This graph is the result for HPLC using 1-propanol as solvent, and the percentage that we got from this is 67.2%. Conclusion. Thus, the process of extraction was successful and considerable amount of extract was collected and identified by HPLC. So, by using 1-propanol, the maximum amount of extract as product was obtained, which is 67.2%. By using acetone, it was 59.7%. Finally, we would like to conclude that by using 1-propanol as solvent, maximum amount of extract is obtained compared to acetone as solvent.